Hello everyone, my name is Eddie Bender, and today I will be sharing with you my final project for ANBI. For my final project, I decided to look at health data, specifically health data on diabetes, um, and I got that data from the Health Facts database, which is in Kansas City, Missouri. That was my structured data. As for my unstructured data, I decided to go with um, something a little more accessible, which was actually Reddit vaccine myths, which I think this time of year a lot of people are getting their vaccines again, so I always um, tend to go towards vaccines around this time of year, which is why I decided to go with that. Let's first go ahead and take a look at the Kaggle datasets here. I got both of these from Kaggle. This original um, code project was trying to predict hospital readmissions based on A1C results. And long story short, which is also described in this description.pdf, long story short, they um, actually, depending on the A1C results, did not show as a factor of whether they were going to return to the hospital, but it was actually a fact of whether they got the A1C result test. If they did, they were actually they were less likely to show back up, but if they didn't, they were more likely to be readmitted into the hospital. Let's go ahead and take a look at this data set though here real quick. So here we have just kind of some generic patient number and counter numbers. They also group the data by race, gender, age, and weight. Unfortunately, weight is missing about 97% of the entries, so when I actually use this data in R, I actually just dropped weight entirely, as it wasn't useful at that point. Admission type ID, discharge, position, yep, admission source, and time in hospital. And there's actually more columns here. Let me select all of them. Go ahead and scroll over more. Time in hospital payer code, which was missing about 40, so I did drop that. Same with medical specialty, I did end up dropping that. Number of lab procedures, number of procedures, and the number of medications. Number of outpatient, number of emergencies, number inpatient, some diagnosis values. Here's the A1C result. A lot of these actually turned out to be none, which is kind of what we discussed. Not a lot of people got the test, which was interesting. But those that did get the test were less likely to be readmitted to the hospital. Here we have some medications with yes, no, steady, and other values. Keep going through here. This is kind of all the same. Whether or not they're on insulin, yes, no, or sorry, steady. The other values are up or down, whether they increase the rate that they're giving it. Diabetes medication, whether just on diabetes medication at all. And this right here is whether they were readmitted or whether they were admitted graded for 30 days. And then there's also some non-answer data in there. Now if we go ahead and go to our studio, I'll show you some of the work I did there. Here, this is kind of basic. We're just reading in the diabetic data. We're cleaning it up by removing those columns that I said we were going to remove. Here is where I was aiming to answer my first research question. My first research question that I aimed to answer was, are people under the age of 50 more likely to be on insulin compared to those over the age of 50? To do this, I had to take this age column here and kind of split it up, create an upper limit value, and then here I altered the medication columns to be if the value is steady up or down, have that equal to 1, and then if the value is equal to no, have that equal to 0. That way, when I was checking for the medications, it would be a lot easier. And I just did this for a lot of the medications. While I really only needed to do it for insulin, I just went ahead and added all of the other ones as well. Scroll down here, and then we plot it out, and we see that actually this isn't the best plot because the number of people under the age of 50 total is vastly outnumbered by the amount of people above the age of 50. So, in order to counteract that, sorry, I went ahead and created a proportion, actually. And here, this shows a proportion of individuals in under the age of 50 and above. And when you look at these proportions, you can actually see that insulin usage under the age of 50 is actually higher than no insulin usage, whereas above 50, no insulin usage is actually greater than insulin usage. And this kind of makes sense when you think about it, because insulin is mainly used for people with type 1 diabetes, which is genetic, and most of the times if you're going to have diabetes under the age, you're not going to develop type 2 diabetes until later in life, just because you get older, your diet's probably not as good as it should be. So if you were to have diabetes under the age of 50, it's probably type 1 diabetes, which means you use insulin. The rest of my graphs and visualizations are aimed to answer the rest of my research questions. Here we see the proportion of individuals on diabetes medication by age group. While it kind of looks like they're the same, they're actually not. They're just really close. And here in the report, here's the description of it. It actually is just off by 1%, which is why it is so hard to see the difference there. We also have this scatter plot here that shows the number of medications that people are taking as they get older. And with this trend line here, you can see that there is actually a positive trend here that as you get older, you do tend to take more diabetes medications. And then here's where we're getting into the unstructured data from Reddit. Here I'm basically doing what we did kind of in the assignments, creating a corpus out of the text and then stripping it down and creating a frequency bar chart. Here we see that people are mainly concerned about vaccines, and hold on, this is different than what I have in the report here. Here we see that people are mainly afraid of, obviously vaccines are talking about that, mainly afraid of autism, as a well-known vaccine myth is that vaccines give children autism, and this data was also taken around the time that measles was coming back in daycares as children were not getting their measles vaccines. Here with the word cloud, we can also see a little bit more. Here they're talking about immunity and mainly focusing on children getting the vaccines. And that covers the R portion of it. Let me go ahead here and show off my story here within Tableau. So here are some of the visualizations I created within Tableau. Go ahead and pull up this one. So this one is kind of similar to one of the ones I created in R. Here we see, this is actually just a count of all the diabetes medications that an age range is taking. So as you can see here, most of the time when you have diabetes, you're going to be taking more medications for it when you're in your 70s and 80s. But this can also be kind of attributed to the fact that when you're in your 70s and 80s, more people do have diabetes, type 1 and type 2. So we go back here, look at sheet number 2. This here is showing the number of procedures versus the time spent in the hospital. So this patient right here had the most number of procedures, and their time in the hospital was 98. That would be 98 days. That'd be 98 days there. Hold on here. What just happened? Let me go back. So this patient was in the hospital for a total of 51 procedures over 98 days, whatever that means for them. Here, this is actually just a sample of the data set because the data set was well into the hundreds of thousands. I chopped it down to about 10,000 data points. And here you can look for a specific one and see where it is. And as you can see, which kind of makes sense, the longer you're in the hospital, the more likely you're to have a lot of procedures. Go to sheet 3 here. And this shows the average time in the hospital, the average time in the hospital per age range. So this is actually kind of interesting. The 10 to 20 age was actually averaging about 4.7 days in the hospital, whereas I would expect this to be lower because they're younger and oftentimes more healthier. I would expect the higher age is to be in the hospital longer. Moving on to sheet 4. Here we are looking at the number of patients per age range in their race. I just kind of found this interesting because I was kind of curious to see which races actually struggle the most with diabetes. And as you can see here, it is obviously Caucasian. Sheet number 5 here. This is actually just looking at the entire number of patients and grouping them by male or female and seeing if they're taking insulin, whether their intake is down, whether they're not taking insulin at all, if their insulin intake is steady, or if it's up. And then here we have the dashboard that I created. So it's basically just the same sheets as before, and here we can, click over here, see African American, Asian, search for certain patient numbers, and yeah, we'll go back here, and then we'll go ahead and actually look at the story. And here's the story that I created. Again, with the same visualizations that I created in Tableau. So here, this is, like I said before, the number of males and females that take insulin and their rate of receival. This one here is the number of patients per race and their age that have been diagnosed with diabetes. Here we have the average time in in the hospital for each age range. And here we have the number of diabetes meds the entire age range is on. One thing that I liked about this project and kind of I noticed as I was going along is that R allows you to kind of nitpick the data for specific things that you want, whereas at least with how far we got in Tableau, Tableau seemed to be a more general way of creating kind of surface level visualizations. I'm sure as you get more advanced with Tableau, you can create the exact same things as you can in RStudio, but that was just something that I noticed throughout my time with this project. And yeah, that is my final project. Thank you.